Hello everybody, this is Sherry Barr again, and we are in week 2. This is unit 2 of the autonomic nervous system. We're going to review that just a little bit. When I went through all your handouts you had for this unit 2, I was a little bit overtaken with it, and I didn't find a lot in your book that you're reading on that. So I kind of shortened this whole unit down quite a bit. More of a review just so you can kind of get a grasp of what the autonomic nervous system does, like a little refresher, so you can remember how then the drugs will react on it. So I didn't get into all of the anatomy of the peripheral nervous system or some of the chemical components of the whole adrenergic and cholinergic receptor sites. So I'm sure you can find that information in probably some of your other books, but it's not really gone into in the book that was provided to me. And I don't want to confuse you at all, so I looked through the your tests and all, and there's not a lot of the chemical part of it other than what I'm going to be telling you. I will review it again, and if there's any other information that you really need to know about that for your testing for this course, I'll be sure to let you know. Most of the information that was provided in those other handouts has a lot to do with some of the things you should have learned in or may learn if you take a future pathophysiology class. So I'm going to bypass that and not utilize that. We're going to just go ahead and do a review first of the central nervous system. It is your primary nervous system for your entire body. It consists of your brain and your spinal cord. From that, you also have your peripheral nervous system, and that's located outside of the brain and the spinal cord, and it has two divisions. It has an autonomic division and the somatic division. After the central nervous system interprets information from the peripheral nervous system, it receives it receives stimuli, and then it responds on and makes a reaction to that stimuli. The autonomic nervous system, which is also called your visceral system, it acts on all your smooth muscles and on your glands. It functions for controlling regulation of the heart, the respiratory system, including your lungs, your GI, your entire GI system from the time it goes in your mouth all the way down to your rectum, the kidneys, your eyes, and your glands. It's an involuntary system, and you have little or no control over how it reacts. Whereas the somatic nervous system, you have control over it. It innervates all of the skeletal muscles, and that's your movement. So anything you have control of moving, that's somatic, and your involuntary then is your autonomic nervous system. Okay, so within the peripheral, your PNS, which is your autonomic nervous system, there are afferent neurons, which is your sensory, and there's efferent neurons, that's your motor. Your afferent neurons, that's your impulse. It sends an impulse or information to the nervous system, the central nervous system, for it to interpret. So you got to think about that. Your afferent, that's the ones, afferent is sending information to the central nervous system, which is your spinal cord and your brain. So afferent means you're sending it to the brain. On the other hand, your efferent motor system, your neuro system is your motor system. That is the one that's receiving information from the brain and transmits this information and impulses through the spinal cord on down to the organ cells. So efferent, it's coming from the brain, it's getting the information and doing something with it down to the cell division where it's supposed to go. And the afferent is where we're sending it out to the brain. Okay? Now, in the efferent, which is the part, that you get the information from the brain. Here's the information, the impulses that are coming from the brain, the efferent side. This then divides into two branches. You have the sympathetic and you have the parasympathetic. These are a set of nerves that both work on the same organs. They can all go to any of the smooth muscle organs in the glands, and they both work on the same ones, but they have opposite responses. It's to provide homeostasis or a balance. The drugs act on these. They're either stimulating or depressing responses. All right? So the sympathetic nervous system is also called the adrenergic system. That's because a long time ago they thought it was adrenaline that was stimulating this system. It's not. The neurotransmitter for the sympathetic side of things is norepinephrine. And there's 4 types of receptor cells within that. That's your alpha 1, alpha 2, beta 1, and beta 2. Okay, so then you have the parasympathetic. It is also called the cholinergic system, and its autotransmitter is acetylcholine. So right, you have your sympathetic and your parasympathetic. Drugs that mimic transmitters, the neurotransmitters norepinephrine and acetylcholine, produce opposite responses to each of the other in the same organ. For example, if you have a sympathetic response to the heart, you increase your heart rate. Whereas if you have a parasympathetic or a cholinergic response to the heart, you have decreased heart rate. Another example of that is a sympathetic response brought on by norepinephrine will constrict blood vessels. And the opposite of that, which would be your parasympathetic response, would dilate your blood vessels. So in summary, just to summarize that, drugs can often either stimulate or block both of these nervous systems. There's a really good table in your book. It's on V1 in the autonomics part, talking about the sympathetic stimulants and the sympathetic depressants, the parasympathetic stimulants and depressants, and their actions. So I'd review that. Now, on this first one, there was a lot more slides, and like I said, I'm not going to get into those. But I just want you to understand the cholinergic receptors at the organ cells are either nicotinic or muscarinic, meaning they are stimulated by the alkaloids, either nicotine or muscarine, respectively. Acetylcholine stimulates the receptor cells to provide a response, but the enzyme acetylcholinase may inactivate acetylene before it reaches the cell receptor. Now that's the part of the parasympathetic, whereas the norepinephrine, always remember, that is from the sympathetic nervous system. So that's about all I wanted to say on that, except for one more little thing here. There are some exceptions to that sympathetic nervous system, and that is that your norepinephrine, that can cause sweaty palms, and that is not a reaction that normally happens within the sympathetic system. That is the postganglionic neurons are involved with. It's a stress-related excretion release of norepi, which causes the sweaty palms. And then the opposite of that though is the involvement of the acetylcholine from the parasympathetic that causes the thermal regulation. Another exception to the sympathetic nervous system is within the kidneys. There is a reaction that goes on to the smooth muscle in the renal vascular bed that reaches dopamine. So that's another one of those little exceptions to the rule. And within the adrenal gland, there is a release of epinephrine into that systemic circulation also. So you don't have to worry too much about all of that, other than just kind of get a grasp on what the autonomic system actually is. and kind of have a good understanding of how each of them interact with each other to kind of counterbalance to maintain that balance, our hemostasis. So just in one more little summary, how do the drugs influence the autonomic nervous system? One, they mimic or block the effects of the two primary neurotransmitters, which are the acetylcholine and the norepinephrine. Two, drugs that mimic neurotransmitters are referred as receptor agonists, and these drugs activate receptors. And three, drugs that block neurotransmitters are referred to as receptor antagonists. These drugs block the neurotransmitter from activating the receptors. Okay, one more thing. Classifications of drugs affecting the autonomic nervous system are parasympathetic or sympathetic. The parasympathetic mimic acetylcholine, which is a cholinergic drug, or they block acetylcholine, which is an anticholinergic drug. Okay, so that's the parasympathetics. They're either cholinergic or anticholinergic. All right? And the sympathetic nervous system, they mimic norepinephrine or adrenergic drugs, or they block norepinephrine, which means it's an anti-adrenergic drug. So I will leave it at that, and we'll move on to unit number 3. Thanks. I'm sure you have more questions about that, but read your book, and if you don't understand it, give me a holler.